Our next guests are two IT experts, each of them with about 2 decades of IT experience. Big data pioneers in Romania, having managed implementations at the powerhouse level. We welcome Alex Matei, CIO Fieldas Trading and former IT and Digital Transformation Director Carrefour Romania, and Marian Simpetru, Managing Partner at eSolution. Marian and Alex will share the story of building first big data platform within Carrefour, from data foundation to horizontally scaling for new businesses needs and governance improvement. Let's hear them out.
Hello, thank you very much.
Hello, welcome.
First of all, I would like to share a little bit about the scope and the agenda of the presentation. We are here to present a successful use case, an implementation of a big data platform. And we're going to start by asking Alex here to tell us a little bit about the challenges that lead to the necessity of implementing such a platform.
Hello, thank you. And first I want to thank you for inviting me here. It's for me, it's quite an honor and a pleasure to join this event together with you, Marian. So getting back to the question, in a big IT ecosystem, there are a lot of legacy monolithic applications that duplicates data from one to another, that drives a huge amount of data that is very, very complex to manage. First challenge was to stop the multiplication of monolithic application and data duplication. In our days, businesses are transforming fast, even so fast, and they need a lot of requirements that are asked to be developed by the IT department. Some examples from retail: real-time or close to real-time information about stock from legacy system are needed by new business functionalities, like in-store picking, stock for multi-store commerce, or express delivery. As you may know, a retail environment, high level, has one system for the physical front office and one system from the back office. The biggest data generator is the front office, hundreds of thousands of transactions per day, but the stock is managed in the back office system. Update of sales in the back office systems are done once per day, during the night, of course, after the day is closed. So the challenge is how we can have all this info about the stock in real time and how we'll be able to serve to other applications. One way of solving this is to transform the monolithic legacy apps and wait years until it happens, or to transform monolithic apps. So in the end of the day, this is mandatory, but not to wait until it's done. In the same time, to gather all business data in one place, in real time, avoid data duplication, create a single source of truth of the data, and start developing new apps based on this new data model. Also, challenges are not related only to the architecture and business needs, are also related to the technical team. Technical team have to embrace new technology and to enter in the mindset of change, learn, and adaptation. IT role in a modern organization is to anticipate business needs and to prepare it in advance the architecture. Otherwise, IT will be at last 2 steps behind the business and the distance will only grow. Nevertheless, it's a matter of cost and benefit. Because it's in the beginning, it's almost impossible to measure exactly the cost and benefit ratio. We have to expect a lot of challenges from our CFO or business controllers. A way of starting is small, but scalable horizontally from the beginning, involving in this progress an agile partner who can support the technical team in the process of co-creating this architecture.
Thank you, Alex. We can all see how many challenges are to be accomplished by implementing the big data platform. I will try further to translate this into some more concrete steps in the technical area a little bit, just to understand how this will cope with the mentioned challenges. previously mentioned challenges. So among the objectives is to prepare an infrastructure in order to accommodate the scalability. You need to be ready to scale not only the platform itself, but the consumers of this platform, because the platform exists in order to serve data for other applications, right? And for this, you better have a unified environment in terms of infrastructure. And nowadays, everything needs to be Dockerized. You need to have a control on top of it, an orchestrator such as Rancher and Kubernetes, and you need to move, if not done it already, into microservices, because this is the way to consume later on huge amount of data, either to ingest or to serve for other consumers, for other applications. Second step, of course, is to install and configure the big data platform. It's something which is tunable later, but yeah, you need to configure the NiFi. This is among defining the architecture, because you need to identify the sources of data, what needs to be done, and we will see later on, and what tool approach what challenge. So besides NiFi, which is used to data collection and transport, you need a storage system such as Hadoop HDFS, distributed file system. You need distributed database such as Cassandra, Redis in order to serve everything extremely fast from memory, Kafka to have message orchestration and streaming, Spark to have streaming and batch processing, parallel processing of the data you have. Then, besides having the infrastructure, you need to actually implement the data flows. Data flows means from the source, which could be files generated by distinct applications, or interrogating databases for some values, or even getting big amount of data into chunks, or small amount of data, but every 5 minutes or so. After you ingest it, of course, you do it to process it and to store it. And this needs to be orchestrated as well in order to have visibility on a long run. Besides that, because we are talking about a distributed system and everything there can be scaled and deployed on many nodes, you need a way to be in contact with the actual operations, which starts to happen once you enter into production. So you need a centralized logging system. Of course, this can also accommodate the microservices that consume and get value out of the data, because in this way it's much easier from the operation point of view to spot problems right from the beginning, and you will avoid the need to investigate sometimes by several engineers where the problem resides among the multiple servers that you have. In order to ensure the operations, continuous operations, of course, monitoring usually it's good to be performed with the tools of choice of the people that will provide the operations and maintenance of the platform later on. And sometimes these include several tools. Of course, in the process, you have to take care on security, because most of the time you need to expose data into external environments, or you need to ingest data from various sources. So everything needs to be done with the security in mind. And in this project, we've implemented the security guidelines that we received on the client side. And not least, a disaster recovery mechanism that allows us to change the data center into cloud. This, I think, it's very nice options in order to ensure business continuity. And nothing will have value without documentation, of course. Documentation is not the Cinderella of a project, because on a project on a long term, this is absolutely crucial, because teams can change, and the customer itself need to have visibility on the actual implementation. So you will need to react much faster in order to do any kind of change or extensions to the platform. Coming back again from the objectives into how we implemented this, I already mentioned Apache NiFi. So you will see in this architecture diagram the full spectrum. It's a very big picture, but we can talk a little bit about the components and what it addressed. We have to think about the challenges. If we have multiple points where you extract data, then the solutions that can deal with that narrows a little bit. So we kind of excluded for some data ingestion flows, other solutions such as Scoop, because NiFi handles a little bit better all the process, and it's very well established and very stable solution. So what it does, it get some data in whatever format. You can create your own agent, or there are already written agents that transports either files or extracts data from a database based on custom SQL queries, and pack them so that it will be either very fast to write or very fast to be read later on, according to the use case further. It can transform the data on the fly. So when it arrives into the data lake, it will have the format that is the most convenient. Of course, this is not a point to insert business logic. This is to be done later on in the processing layer. So storage, of course, it's a distributed file system, Hadoop. And from this, we feed the batch processing layer, because sometimes data arrive as a file with many entries, and they need to be processed as such. And for that, we used Apache Spark together with Kafka for things like computing delta, for instance, delta between the previous situation and the now situation, in order to offer a very customized view on the data. So we can serve APIs with only differences from the previous interrogation, for instance. On the other side, we've implemented event sourcing. So for every microtransactions in terms of data processing, we implemented Kafka streams. So we could implement real-time or near real-time data changes flow. All of these were later on stored in more structured, well, if we can call it like that, because they are the in the world of NoSQL. We store the data in Cassandra. We store data in Redis according to the further usage of the data. And for instance, in Redis, which is in memory implementation, it's like a caching layer, only, I would say, smarter and better and very fast. We used information like current stock or current product information. For instance, everything that we know about one product is stored there, and it's served when interrogated by an API extremely fast, and it's extremely accurate, because this is where all the data with real-time or near real-time changes will be updated. Of course, into this platform, you don't have always the luxury to implement something from the scratch. It's not an empty ecosystem and you build it from the beginning, but instead you have to cope with legacy applications. You have to cope with, let's call it standard enterprise storage solutions or databases. You have to put them to work into the new context. So we just integrated existing solutions and storage systems into the platform. So we've made like a customized platform in order to serve the needs. As you could see by now, the main focus of the implementation was to give the business the opportunity to have new requests, new implementation, and to make things possible. And this, of course, came from the challenges, came from the challenge came from the big numbers that we are talking about. So you should imagine that a company with, for instance, a portfolio of more than 100,000 items that it's currently having changes into the inventory and has real-time sales information in more than 300 places, stores. Then if you multiply that, you can see the challenge. There are millions of rows that needs to be generated very often and transformed into current situation, current stock, numbers in sales. And why is this needed? Because we need to feed the data to mobile applications. We need to feed the data to systems that will trigger some alerts on various business aspects. And sometimes it's just about making the data available on request and being able to scale ad infinitum, because you for sure already know that big data tools are specific in the way that they can scale. And when we talk about scalability, it's totally different than a speech about scalability 10 years ago in Romania, for instance, where prepared to be scaled sometimes only meant a cluster of 2 servers or a modular architecture that allows you to write plugins onto an already fat applications. Right now, we are talking about the ability to have infinite numbers of nodes, and we are talking about that, and it's possible to have big number of Kafka nodes or Cassandra, for instance. Is the same with the processing power and the storage, absolutely the same idea. All of these, they are not, let's say, things that were discovered by us. They are mainstream in the wild. They were invented by, of course, huge companies and contributed to the open source environment to be further maintained and developed. All the big giants in the industry, in social media and the IT industry use exactly this technology, of course, tune up with different flavors. I propose you to talk a little bit about the results of implementing such a solution. So we are talking about implementing a big data platform mainly to serve the operations into a large retailer. And the results are that we could transfer any kind of data, any kind of information from any location, any shop, into the big data platform. So if, for instance, I would like to know how many kilos of apples do we have right now, we can do that. And in maybe 10 minutes, we will get an update about that for everything. And we are talking about not only physical shops, but also an express delivery solution application or and an online shop on top of that. And we are talking about 100,000 items and more. And yeah, these are rather old numbers, because even though the stock numbers are rather correct, the API calls are continuously increasing, and they come in batches. So the challenge is not that, okay, we spread that among one day. They come with the usage, and the usage is dictated by the client applications, and we just have the ability to scale to whatever load is required. We were pretty fast, so we came to I would say a resume. So maybe Alex can share a little bit some information what people might
Yes.
should remember after our very quick presentation.
Sure. From my perspective, my personal perspective, the most important thing of implementing this project is the fact that, as I see it in this moment, it acts practically as a middleware between the legacy application and also to the new application. It's a layer of integration and also a layer of development with new software technologies that bring us, first of all, speed to react in terms of new functionalities. It gives us a lot of visibility about the information that are needed in certain processes. And also it opens a way to think differently and to have the solution for the thing that 2 years ago we cannot imagine that we can have. Also, a big step forward, in my opinion, was the fact that this platform it's replicated into the cloud. So, as Marian said, business continuity is solved, because it can be also a problem with this huge amount of data and technologies to have it in one place and to replicate them all into the cloud. In order to stay very flexible and maybe someday to switch to the cloud or to have new possibilities in front. So the idea is to go very flexible, very scalable, and to get all the benefits that we can have from the technologies. So of course it's open a new era for the data science, for the predictive models and so on. So in my opinion, it was a huge project. It's the foundation of the new architecture. Is not only of the data. It starts with the data, but it's not only data. It's a whole new architecture of the future.
Yeah, thank you, Alex. Actually, you touched a point that I want to mention. We already started a similar project for leveraging the capabilities of a big data platform, only this time in cloud. Of course, there are different objectives, more related to data science, analyzing the data, reporting, and getting some clues out of the data and some business insights out of the data. And we run now a project in Google Cloud this time, and it's with an international participation on the side of the customer. Yeah, I would like to address you one question, because you were part of the implementation, of course, and you have a different view than I did over the project. What's your opinion? What was the most difficult part into implementing that, into implementing the platform?
In my opinion, it was not a difficulty in the technical process of doing it. Of course, until we connect all the NiFi clients, we take all the relevant data, we assure that everything is working, in my opinion, is part of the process. I think the most complicated thing is to have all the developers in this new data-centric architecture and to make them understand that this is the way of the modern architecture and how we can advance very fast based on this kind of big data, cloud big data architecture, because it's more like this.
Thank you very much. I would like to...
Thank you also. And I have also a question for you that came through our chat. Victor is asking what technology, what tool is used for disaster recovery on premises, big data platforms?
Oh, there is not a specific tool. There is a combination of tools, and it's a lot of scripting, configuration, and also data transport. And we replicated configuration. This is the most important thing, because it's not always about the data, because the data you can recover, but it's about reconstructing the environment, right? Nobody will erase the history out of the source, especially that we have it in multiple points, but it's all of this is about how fast you can restart a platform into a different data center or in the cloud. So we kind of took care on these regards mostly, into having the platform up and ready. I have one more mention, to like a surprise at the end of the presentation, and with this I will rest my case. I would like to announce that if anybody will come to us to eSolutions by the end of the week and will request an assessment about the opportunity of implementing a big data platform, either on premise, either on cloud, and we are offering this assessment for free. So if you are in this position and you still have doubts or questions about this, maybe implementation time, maybe you want to discover or have a little clues about the cost for that and what it involves, we are there for you, and we are now offering this for free for our audience here. Thank you.
Great. Thank you both. Thank you, Marian. Thank you, Alexandru. It's time for us to close this session. We have reached now the first networking break. So take this time to visit the Digital Expo area and find out what our partners set up for you. We have insightful case studies, white papers, infographics, guides, videos, games, and more, only one click away. We meet back here after the break. Please note, each session is broadcasted individually, so make sure you check the live session tab when returning. Thank you again.
Thank you. Bye-bye.
Bye.